Hello friends, in this video we are going to discuss a numerical on thermal equilibrium concentration of n-type semiconductor. In this numerical it is given the thermal equilibrium electron concentration for a n-type semiconductor are given below, and there is a graph given. In the graph, in the y-axis it is written as electron concentration, and in the x-axis we can see reciprocal of temperature. And there is a graph given, and there are three regions has been defined, and we have to identify the regions A, B and C. Now for this question we know that this electron concentration inside an n-type semiconductor is solely responsible for the conductivity of the n-type semiconductor. So we can say that the conductivity of an n-type semiconductor is being plotted on the y-axis, because electron concentration and conductivity of an n-type material is same thing, because electron concentration will control the conductivity of n-type material. So we can say that it is a graph in between conductivity of n-type material versus 1 by temperature. Now we know that the graph of conductivity of an extrinsic semiconductor with temperature looks like this one. This is the graph. We already know that it is at 300K. This is 0K. This is the conductivity maximum value. Now if we plot this graph as 1 by T in the x-axis and sigma in the y-axis, then it will look like this one, this type of region. So we can see this graph is given in the question. In this region, if I denote this region as A, if I denote this region as B, and if I denote this region as C, then we can write this is the A region, because it has been taken as a reciprocal. This will be the B region, and this will be the C region. A region is named as, this A region is called as the ionization region, because the conductivity is being increased due to the ionization phenomena. And conductivity in the B region, it is the extrinsic region, where the conductivity decreases with the temperature. And in the C region, here the conductivity is sigma, that is the intrinsic conductivity, because the intrinsic conductivity has been converted to intrinsic semiconductor at Curie temperature Tc. So at this temperature, the semiconductor which was extrinsic semiconductor is now converted into intrinsic semiconductor. So the region C is named as intrinsic. So from this graph we can say that this A region will be called as, this A region will be called as, this A region is same as this C region, because here it is 1 by T. So A region will be called as intrinsic region. Similarly, the B region will be called as the extrinsic region, and the C region will be called as ionization region. These are the name of the region that we have to identify. That's why in this way we can find, or we can identify the regions inside the graph that is given in the question. This is all about the numerical on the conductivity of extrinsic semiconductor. Thank you.